Ever wonder if there are brilliant minds out there whose ideas are so far ahead of their time they almost, get lost in the shuffle?
Oh, absolutely.
Minds that saw these really profound connections between forces we still struggle to unify. Ideas that might just, fundamentally shift our entire understanding of reality.
Indeed. What is some of the most profound insights into gravity and electromagnetism came from someone who wasn't just thinking outside the box, but living in a completely different dimension of thought?
Mm-hmm.
Someone whose work, even now, is still being meticulously unpacked, prompting us to reevaluate what we consider settled science. It's fascinating stuff.
Absolutely. Today, we're taking a truly wild deep dive into the extraordinary work of a remarkable individual, Thomas Townsend Brown, a visionary inventor and scientist whose lifelong quest explored the tantalizing, deeply intertwined link between electricity and gravity.
That connection, yeah.
And you, our listener, have given us this incredible treasure trove of his documents, so everything from his early autobiography to dense scientific journals and highly classified project reports.
A real goldmine.
Totally. Our mission: to distill his most mind-bending theories and awe-inspiring applications, presenting them without judgment, just pure, unadulterated exploration of the ideas themselves. Prepare to have your assumptions about physics and maybe even reality itself gently but firmly nudged.
That's right. We'll trace his fascinating journey from moments of youthful ingenuity to these profound theoretical leaps, examining concepts that were considered, rank heresy in his time.
Rank heresy, I love that.
And still robustly challenge conventional wisdom today. We're talking about a true pioneer here, someone who saw the universe through this unique, interconnected lens. What's particularly striking is just how early his extraordinary genius began to, express itself.
Okay, let's truly unpack this. Our journey begins with the early sparks of a prodigy, specifically his absolutely wild ride into the nascent world of radio technology.
Right at the beginning.
Imagine, at just 16 years old, back in 1922, he had this uncanny, intuitive feeling that Dr. Lee DeForest's brand new vacuum tube, famously known as the Audion.
Revolutionary device.
Totally. For amplifying weak electrical signals, was gonna absolutely blow past the simple crystal detectors everyone else was using at the time.
Mm-hmm. Like galena, silicon.
Exactly. He'd experimented extensively with those, like galena or silicon, even noting that galena gave him superior results to silicon for his own setups. But he knew deep down that the vacuum tube was the undeniable future of radio.
And what's truly fascinating here, beyond just his technical intuition, is the sheer audacity of youth.
Oh, yeah.
He was so utterly convinced that he, a mere teenager in Ohio, needed these tubes not just for receiving signals, which was, pretty common,
right,
but for transmitting to set up his own broadcasting station. So on a trip to New York with his mother, he decided there was only one logical course of action.
You're kidding. What did he do?
He looked up DeForest's name in the phone book and called him directly.
No way. At 16. Just calls up Lee DeForest.
Can you even imagine? The sheer nerve, and the story, according to his own recounting, gets even better.
Okay, I need to hear this.
When he called, a servant, or maybe a very proper assistant, answered and told him Dr. DeForest was, quote, in his bath.
In his bath. Classic.
But when our young man declared with utmost seriousness that he wanted to buy tubes specifically to set up a transmitting broadcasting station in Ohio, DeForest himself was reportedly on the phone immediately.
Wow.
Not only did one of the most influential inventors of the age interrupt his bathing routine, but he proceeded to supply the tubes at a not exorbitant price.
That's incredible. A 16-year-old making deals with a titan of industry, it really speaks volumes about his conviction, his charisma, even back then.
And the impact of this audacious move was profound. He went back to Ohio and, with those precious tubes, established a 10-watt radio telephone station, proudly bearing the call signal WJD.
WJD, okay.
And this wasn't just some casual hobby project. This was potentially one of the very first broadcasting stations in the entire United States, possibly even predating famous, commercially recognized ones like WJZ in New York and KDKA in Pittsburgh.
Wait, really? Predating KDKA? That's huge.
Think about the implications. A teenager intuitively understanding, designing, and implementing broadcast technology before it was even a widespread public concept, essentially laying down the groundwork for an entire new medium of communication.
It's utterly mind-blowing. And the tangible proof of his reach, the sort of indisputable evidence that this young man was truly breaking barriers from his own backyard.
Yeah.
He received a postcard all the way from California, unequivocally confirming his tiny 10-watt broadcast had been heard across the entire North American continent.
10 watts, coast to coast.
That's like sending a Morse code message from your garage today and getting a reply from the International Space Station. It just defies the assumed limitations of the technology and the era.
And even with the practical challenges inherent in pioneering such technology, his ingenuity consistently shone through.
Like what?
Well, his Green Imps Orchestra broadcasts, a true early form of entertainment radio, were often cut short because the university generator at Denison would turn off the lights promptly at 10 p.m.
Ah, party pooper generator.
Right. Most people would have just packed up, called it a night. Not him.
Okay, what did he do?
He simply devised an emergency Delco system. Think of it as a self-contained battery-powered generator like they used for rural electrification back then to keep the broadcasts going until 11 p.m.
Ah, brilliant. Resourceful.
It's a powerful testament to his unwavering resourcefulness, his determination to keep his passion alive, and his remarkable ability to solve complex engineering problems no matter the obstacle. That level of drive and creative problem-solving was, well, it was a hallmark of his entire career.
Pure genius, deep curiosity, and relentless grit, wouldn't you say?
Absolutely.
So from these electrifying early radio days, his path took a truly fascinating, pivotal turn to the Naval Research Laboratory, or NRL, in Washington, D.C.
The NRL.
He himself described this as a happy event, perfectly combining his two core interests, his profound fascination with the Navy and his insatiable drive for scientific research. And here's where his story takes an even more intriguing twist. He arrived at the NRL as a mere apprentice seaman, like the lowest enlisted rank.
Right at the bottom.
Yet was immediately welcomed by Commandant Captain Almy with an almost unprecedented status, that of a junior physicist. He wasn't just given a desk, he had his own lab room, complete with his name proudly displayed on the door.
Wow, that's unusual for an apprentice. Almost privileged status. He gravitated towards the Heat and Light Division, working under Dr. Edwin Hulbert.
And why that division?
His choice was deliberate and telling. It was driven by his long-standing, almost obsessive interest in radiation, especially cosmic radiation, which just happened to be Hulbert's specific area of specialization.
Ah, okay, so not just a random assignment.
No, this wasn't just a career move. It was a clear continuation of his deep-seated curiosity about the most fundamental forces of the universe. He was pursuing a question that had clearly captivated him for years.
And this is precisely where his lifelong quest to understand and even control gravity began to take a truly controversial and paradigm-shaking shape.
Here we go.
While immersed in his work at the NRL, he conducted a series of experiments that, to him, seemed to prove the concept of gravitation that he had first hypothesized years earlier, all the way back in 1923, during his time at Caltech.
So this idea had been brewing for a while.
Exactly. It was a theoretical framework that had clearly been percolating in his mind for quite some time, and now he felt he had empirical evidence to back it up.
What's truly fascinating and deeply telling about the scientific landscape of the era is the immediate, visceral, and incredibly strong reaction from the established scientific community.
They weren't fans.
Not exactly. The results of these experiments were not just debated. They were met with outright controversy, even from his direct superiors, Dr. Hulbert, and his assistant, Dr. Ross Gunn. Gunn famously and quite bluntly remarked with an almost dismissive fury, Brown's work wasn't worth the powder to blow it up.
Ouch. Wasn't worth the powder to blow it up. That's brutal. What on earth was he observing to get that kind of reaction?
It's a statement that leaves you utterly wondering what exactly he was observing, and how profoundly it challenged the prevailing understanding of physics to provoke such a harsh, almost angry response. It underscores the immense challenge of introducing truly revolutionary ideas that shake the very foundations of accepted scientific principles.
Yeah, no kidding. That's a truly brutal mic drop moment in the history of scientific dismissal right there. But the universe, or maybe destiny, had even more extraordinary experiences in store for him.
Seems like it.
The very next year, an unexpected, almost cinematic opportunity arose. He was invited to assist the renowned Dutch scientist Dr. Venning F. Meinesz on a historical, truly unprecedented expedition.
Dr. Meinesz. Okay, this sounds important. This was undeniably a critical juncture in his life and scientific journey. Dr. Meinesz, working in collaboration with Princeton University's geology department, was undertaking a vital gravity survey of the South Atlantic.
A gravity survey? From a submarine?
Exactly. This wasn't just an academic exercise. It was crucial for advancing the fields of geophysics and refining theories relating to the Earth's origins and internal structure, conducted from the unique platform of a U.S. submarine. It shows that intersection of his naval background and his scientific pursuits.
And the stakes were incredibly jaw-droppingly high. The expedition involved dives to extreme, unprecedented depths, up to 4¼ miles, which is a staggering 4,862 fathoms.
4¼ miles deep.
In water, far too deep for any rescue operation. Yet, in a testament to the scientific dedication and perhaps a touch of grim resolve, the USS Chewink rescue vessel accompanied them, a brave but perhaps ultimately a futile gesture if something went truly wrong.
Wow. That highlights the profound lengths and dangers scientists would undertake in the pursuit of fundamental discovery.
Absolutely.
And a truly surprising and almost serendipitous detail for me digging through these documents was the discovery that Hyman Rickover—
Wait, the Hyman Rickover, father of the nuclear navy.
The very same, who later became the celebrated retired admiral of nuclear fame, was actually a member of that very submarine crew.
No way! That's wild.
Isn't it? This seemingly unrelated naval expedition, deep under the ocean, must have further ignited his personal delight, finally fulfilling a long-held desire to be a seagoing sailor. This deep-sea experience, far from being a diversion, was, in a profound way, subtly foreshadowing, and perhaps even informing his lifelong pursuit of understanding the fundamental nature of gravity and how it might interact with other forces in extreme conditions. It demonstrates how even seemingly disparate experiences can feed a deeper, lifelong intellectual quest.
From the crushing depths of the ocean to the mind-bending depths of theoretical physics.
Right.
Okay, this experiential journey leads us perfectly into the absolute core of his life's work. Electrogravitation and its truly mind-bending implications.
Right. This isn't just about tinkering with electrical circuits. It's about proposing a whole new, interconnected way of looking at the very fabric of the universe.
So let's get into it.
At the very heart of his theoretical framework was what would later become known as the Biefeld-Brown Effect, a phenomenon he extensively explored under a classified initiative called Project Winterhaven.
Project Winterhaven. Sounds mysterious.
It does. The central hypothesis was audacious, bordering on revolutionary. A fundamental interlocking relationship exists between the electrodynamic field and the gravitational field. And here's the crucial radical part, that this interaction may be electrically controlled.
Okay, now, for those of us who aren't quantum physicists or theoretical engineers, how do we ELI5, this electrically controlled part? What does that truly mean in practical terms, and how does it challenge our everyday understanding of physics?
Right, good question. Imagine it like this. Current mainstream physics largely treats electricity, magnetism, and gravity as separate fundamental forces, right? Even though we know they interact in certain ways. What he was proposing through his research and experiments was that they are far more deeply intertwined, almost like different facets of the same underlying fundamental force. And critically, that by manipulating extremely powerful electric fields in very specific ways, you could directly influence, perhaps even control, gravity itself.
Control gravity with electricity.
That's the core idea. It's like finding a master key that doesn't just open one lock, but multiple, seemingly unrelated locks simultaneously. And he wasn't alone in this grand, sweeping vision. Dr. Paul Alfred Biefeld.
Okay, that's the other name in the effect.
Exactly. Notably described as a colleague of Albert Einstein in Germany and a respected professor of astronomy at Denison University, formerly subscribed by affidavit that the observed effects, in his opinion, did represent an influence of the electrogravitational field.
Whoa, hold on. A colleague of Albert Einstein himself weighed in and gave an affidavit saying he saw an effect.
That's what the record states. This provided crucial early validation from a highly reputable academic figure, giving significant weight to the early controversial findings.
That's some seriously powerful, albeit controversial backing. And Project Winterhaven, the initiative backing this research, certainly wasn't shy about its ambitions.
No, they weren't.
Its sponsors clearly believed, as the documents reveal, that the technical development of the electrogravitic reaction would usher in a new age of speed and power and of revolutionary new methods of transportation and communication. I mean, they were thinking on a truly cosmic scale, like intergalactic star travel, big.
They absolutely were. This wasn't just about faster cars. It was about reimagining how we move through the cosmos. The theoretical considerations derived from this research predicted that because of the privilege of sustained acceleration, the top limits of speed may be raised far beyond those of jet propulsion or rocket drive.
Sustained acceleration beyond rockets. How?
This implies a form of propulsion that doesn't rely on expelling mass, like conventional rockets pushing against exhaust.
Right, action-reaction.
But rather on actively manipulating the very fabric of space-time around the craft. Imagine not pushing against the air or expelling fuel, but literally creating a localized warp in gravity that pulls you along. That's a huge, almost unimaginable leap from any conventional propulsion we currently understand or even widely theorize about.
Okay, so this electrically controlled gravity thing leads to a concept that completely redefines how we think about something as fundamental as mass and weight. His radical idea of gravitational isotopes.
Yes, gravitational isotopes.
So for us mere mortals, those of us who aren't sitting around contemplating the subtleties of gravitational fields, what exactly are these gravitational isotopes? How do they flip our understanding of what it means to be heavy or light?
Okay, think of it this way. Under normal circumstances, in our everyday experience and in mainstream physics, we assume that an object's gravitational mass, how strongly gravity pulls on it, is precisely and intrinsically equal to its inertial mass, how much it resists acceleration when a force is applied.
Mass is mass.
Pretty much. This is a cornerstone of Einstein's general relativity, known as the principle of equivalence, where the ratio of gravitational mass and mg to inertial mass is considered constant and equal to 1. He termed this the GI ratio.
So mg over my normally equals 1. Simple enough. But he had a truly mind-bending twist to this, didn't he? A way to fundamentally alter that ratio.
Exactly. He proposed that for gravitational isotopes, this GI ratio is not constant or necessarily unity. When this ratio is less than unity, the acceleration due to gravity is less, leading to what he termed light gravitational isotopes.
Lighter than normal.
Right. Conversely, when the ratio is greater than unity, the opposite occurs, meaning heavy gravitational isotopes prevail. He theorized that you could theoretically literally make materials lighter or heavier by influencing this fundamental ratio through various means.
Okay, hold on. Make things lighter or heavier just by doing something to them, not adding or removing stuff.
That's the implication. Imagine the implications. If you could truly manipulate the GI ratio, you could engineer materials that are virtually weightless for building colossal skyscrapers that defy traditional structural limits, or design space launches that become vastly more efficient because the craft itself could be made lighter.
You change everything.
This isn't just a lab curiosity. It's a conceptual blueprint for an entirely new era of engineering and space exploration.
That's truly incredible. And he wasn't content just theorizing. He was proposing how to achieve this.
Right.
His notes from January 1956 outline several astonishing methods for creating these lighter-than-normal materials. So how did he suggest we could actually do this? What were his practical steps for manipulating gravity on a material level?
He detailed several intriguing, almost alchemical methods. One was the irradiation of materials like loess, that fine-grained, wind-blown sediment.
Right, loess soil.
Using various forms of electromagnetic radiation, visible light, ultraviolet, X-rays, and even gamma rays. The idea was that this exposure would produce lofting particles that would then decay and eventually return to Earth, demonstrating a temporary change in their gravitational properties.
Lofting particles. Okay. Right. What else?
Another method involves spark-low gas, specifically by applying positive sparks, ultraviolet light, and electric discharge to the material. He also suggested pulverizing materials through additional grinding, which he termed mechanical irradiation, implying that even intense mechanical stress could alter these subtle gravitational properties.
So just vigorously grinding something could make it lighter. That's definitely not what you learn in any standard high school physics class. That's truly thinking outside the box, or perhaps even outside the known laws of physics as we currently understand them.
Indeed. And perhaps most startling, and certainly provocative, he suggested exposure in or near atomic piles or sites of nuclear explosions.
Wow. Okay, nuclear exposure too.
The mind-blowing implication here is the possibility of creating or energizing materials lighter than normal, with truly revolutionary applications. He envisioned a future where we could actively manipulate the very weight of objects, not by traditional means like buoyancy, but by fundamentally altering their interaction with the gravitational field. It's a vision that fundamentally redefines what mass means.
This challenges everything we thought we knew about gravity and mass, particularly when you consider its implications for Einstein's theories. So, was he saying Einstein was wrong about the equivalence principle, which is like a cornerstone of modern physics? How did he attempt to reconcile his seemingly radical ideas with such a foundational pillar?
This is where his ideas become truly provocative and nuanced. He wasn't necessarily saying Einstein was wrong outright.
Okay.
Rather, he argued that Einstein's principle of equivalence, which states that gravitational mass and inertial mass are equal, holds true only when weak fields are present or utilized in the experiment.
Only in weak fields.
That was his contention. He firmly believed that strong fields would, I believe, show non-equivalence. This is a subtle but profound distinction.
So it's not a blanket contradiction, but rather a conditional one. He's suggesting that if the gravitational or electromagnetic fields are strong enough, the rules might subtly change, revealing a deeper layer of reality. That's a truly profound distinction.
Exactly. He pointed to the original Iakfos experiments and later repetitions by Dick, which famously confirmed the equivalence principle to extreme accuracy down to 1 by 10^11.
Right, super accurate.
But always, crucially, in weak gravitational fields, like those naturally present on Earth's surface. He theorized that our current understanding and the very confirmation of equivalence is limited by the very conditions under which we test it.
So we're only looking where the light is good, so to speak.
In a way, yes. To prove his point and to demonstrate the non-equivalence in strong fields, he proposed a specific, ingenious test, his centrifugal differential hydrometry experiment.
Sounds complex.
He lamented in his 1973 notes that this experiment had already been inexcusably delayed for 17 years, calling it an inexcusable neglect by the scientific establishment.
17 years. He must have been absolutely itching to see this tested. What exactly was this centrifugal differential hydrometry experiment designed to do, and why did he believe it was the key to unlocking this hidden layer of gravity?
He believed this experiment might produce materials whose gravitational mass differed greatly from their inertial mass. In essence, it was an attempt to create those gravitational isotopes under controlled strong field conditions by using extreme centrifugal forces to amplify any subtle non-equivalence.
Using spin to force the issue.
Precisely. This isn't merely another experiment. It's a direct, almost audacious challenge to a cornerstone of modern physics. If he were proven right, it would mean that while Einstein's equivalence principle holds true in weak fields, there's a hidden layer to gravity that only reveals itself under extreme conditions.
Wow.
It would open up entirely new avenues for propulsion, energy generation, and even fundamentally alter our understanding of space-time itself. It truly invites us to question the assumptions built into our most foundational scientific principles.
This is truly mind-bending stuff, transforming abstract theory into potentially revolutionary capabilities. You know, if you're as hooked as we are right now, and you love having your mind stretched by these incredible insights and the tantalizing possibilities they present, then you know what to do.
Yes, absolutely. If you're enjoying this deep dive into the truly unconventional, into ideas that could literally reshape our world, please take a moment right now. Like this deep dive, subscribe to our channel, and definitely consider joining our memberships.
Yeah, do it.
Your support really helps us keep exploring these uncharted territories of knowledge and bringing you more of these aha moments. It allows us to spend the time needed to unpack these complex ideas and make them accessible for curious minds like yours.
It really does make a huge difference. So hit that like button, subscribe if you haven't already, and come be part of our community as we continue this journey.
Okay, with our minds firmly stretched and our imaginations firing, let's talk about the ultimate, most awe-inspiring application of this electrogravitic theory. His astonishing flying saucer design.
Flying saucers?
And get this, he was sketching and conceptualizing these designs before the term flying saucer even became a newspaper topic, long before public fascination with UFOs took hold. He was conceptually building these devices on paper and in early prototypes, long before the popular imagination even conceived of them. The core propulsion principle is truly revolutionary. These devices have no propellers, no jets, no moving parts at all.
No moving parts. How does it move then?
Instead, they create a modification of the gravitational field around themselves, which is analogous to putting them on the incline of a hill.
That's a fantastic ELI 5. So they're not pushing against anything, they're not expelling anything. They're essentially creating their own localized gravitational slope to slide down, and then they take that slope with them.
Precisely. He vividly likened it to a surfboard on a wave.
Mm-hmm.
The electrogravitational saucer creates its own hill, which is a local distortion of the gravitational field. Then it takes this hill with it in any chosen direction at any rate.
Surfboard on a wave, it creates itself. Okay, I can picture that.
To elaborate a bit, his theory posited that by applying extremely high voltages to asymmetric electrodes, a powerful, shaped electric field is created. This field, in his view, would then locally distort space-time, effectively generating that gravitational gradient, or hill, for the craft to slide down. Imagine creating your own localized warp bubble that you could direct.
That's a visually stunning and powerfully evocative way to put it. And there's a characteristic visual signature associated with his experimental devices, and later observations attributed to similar phenomena is that there's something that people have reported and theorized about for decades.
Yes, reports consistently described a characteristic glow, usually of blue or violet color, around a periphery of the objects.
The classic saucer glow.
Right. Physicists noted this as characteristic of a very high voltage electrical discharge, similar to corona discharge. He theorized that this luminous phenomenon wasn't just a side effect or atmospheric ionization. It was an essential and visible manifestation of the high-voltage electrical activity critical to the craft's operation, a direct indicator of the powerful fields at play.
So the glow is the engine, in a way. And he didn't just stop at theoretical diagrams. He had practical units for this, didn't he? These actual physical designs he called dynamic counterberry units. What do they look like in his notes, and how do they function at a more granular level?
His notes describe these units as specific arrangements where regions of high flux density immediately about electrodes cause electrodes to be lifted. He envisioned them as modular components that could be scaled.
Okay.
A basic requirement for this propulsion, he stressed, is meticulous field shaping, directing and concentrating the electrical field. This was often achieved using a central pylon and a toroid, a donut-shaped electrode, specifically designed to concentrate high flux fields at the cathode negative end.
The toroid, the donut shape. Got it.
This carefully sculpted, highly energetic field is what, in his theory, generates the lifting and propulsive thrust.
So it's all about precisely directing that immense electrical energy to sculpt the gravitational field. And for stability in flight, especially for something as ambitious as a Venusian scout ship, a phrase straight from his own notes, which is amazing.
Venusian scout ship.
He even had a sophisticated gyro stabilization system. How would that work in a craft with no conventional moving parts like a propeller or jet engine, let alone a mechanical gyroscope?
His idea was quite ingenious and deeply integrated with his electrogravitic principles. He proposed rotating a cathode toroid in one direction and a control grid in the opposite direction.
Counter-rotating electrical parts.
Exactly. This counter-rotation, achieved not mechanically but through electromagnetic coupling between their magnetic and electric fields, would provide gyro stabilization for a craft. It would prevent undesirable wobble or oscillation during both hovering and high-speed flight, ensuring directional stability. It's an elegant solution that integrates the propulsion system directly with stability control, a testament to his holistic approach to design.
Wow, okay, from theoretical flying saucers to the Earth itself, his insights truly extend to what he termed nature's own electrogravitic machines. He had a fascinating hypothesis about the Earth's very rotation, didn't he? Something about how it might be subtly influenced by these gravitational isotopes?
Yes, in a February 1956 entry, he posited a truly grand idea that the Earth's rotation might be subtly yet significantly influenced by gravitational isotopes and its interaction with the sun.
How so?
He hypothesized that on the daylight side of the Earth, constant solar irradiation causes increase in inertial mass, which would tend to slightly decrease that side's rotational velocity.
Okay, slows down a tiny bit in sunlight.
Right. Conversely, on the night side, away from direct solar radiation, he theorized that a decay causes decrease in tending to slightly increase rotational velocity.
Speeds up a tiny bit in the dark.
Exactly. Since both these subtle forces would act in the same direction, contributing to the overall rotation, they would result in a contribution to the orbital motion. It's a truly cosmic idea, suggesting a fundamental, continuous interaction between solar radiation, the Earth's mass properties, and its celestial mechanics, subtly influencing its journey through space.
That's a scale of thinking most of us can barely grasp, that our planet's very movement might be subtly swayed by these invisible forces. But what about his observations of strange behavior of the rock sensors? This sounds like something straight out of a forgotten sci-fi novel. He believed that even common rocks could generate an electric current.
It's quite remarkable and genuinely intriguing. He observed that even a single ordinary rock, when set up in a specific way, could mysteriously generate an electromotive force, EMF, implying it was continuously losing energy.
A rock producing voltage.
Yeah, this led him to the logical conclusion. If the rock is to remain stable and not simply dissipate, it must be receiving energy at the same rate it's losing it.
Makes sense.
He therefore theorized that rocks constantly receive and re-emit energy, possibly gravitational or an unidentified radiation. He believed this effect was profoundly influenced by ambient domains with characteristic spectral signatures, suggesting a subtle, pervasive energy field interacting with geological materials.
So rocks are like tiny, natural batteries constantly interacting with some unknown cosmic energy.
In essence, he saw rocks not as inert objects, but as tiny, constantly interacting transducers, subtly exchanging energy with unseen forces. And he even found a way to amplify this.
That's an astonishing claim.
Indeed.
Amplify it how?
He found that by applying a specific bias voltage, he could significantly increase the sensitivity and conductivity of these rock sensors. This, he theorized, would polarize them and facilitate charge carrier separation within the rock's matrix.
Okay.
This could lead to a high current output from seemingly inert materials, specifically mentioning concrete blocks electrically polarized while curing and then connected in series.
Wait, concrete blocks as batteries, like build a dam and power a city.
Imagine the implications. Vast concrete structures like dams or buildings potentially acting as massive self-charging power sources. This is an astounding claim, suggesting a novel, abundant, and potentially limitless way to generate electricity from the most mundane of materials.
A truly surprising discovery, if valid, as he himself noted in June 1976, hinting at the revolutionary nature of the idea even for him.
Yeah, even he seemed amazed by it.
And speaking of surprising discoveries and challenging conventional wisdom, he also hypothesized that an overloaded resistor may become a battery. Now, that completely defies our basic understanding of electronics. How does that even work? A resistor, by definition, consumes energy. It doesn't create it.
His notes suggest a truly counterintuitive process. He theorized that by subjecting long wires of massive materials like tungsten, that metal known for its high melting point and electrical resistance,
Like in light bulbs,
to a high initial DC current above their Curie point and then slowly cooling them, they could retain a form of electrical polarization and generate a continuing self-potential.
Whoa. The Curie point, just to clarify, that's the temperature where magnetism changes, right?
Exactly, where a ferromagnetic material loses its permanent magnetic properties. His idea implied that exceeding this threshold, combined with specific current application and cooling, could induce a persistent electrical charge, turning an energy consumer into an energy source. It truly highlights his willingness to challenge the most fundamental assumptions of electrical engineering and material science.
What's truly fascinating here is how all these seemingly disparate observations, from flying saucers to the electrical properties of rocks, all tie back to his core unifying idea of electrogravitic interaction.
It all connects.
And he took this even further, proposing an Earth movement sensor. What was that all about? How could a simple sensor detect the planet's absolute motion through space?
He introduced the concept of a semiconducting rod acting as a gravitator, a device he believed could be sensitive to the absolute motion of the Earth through space.
Not just earthquakes, but motion through space.
Yes. This wasn't just about detecting tremors. He theorized it could infer both the Earth's direction and the extent of its movement. His theory was that merely rotating this gravitator would cause a change in resistance, meaning it could essentially act like a motor or a generator.
Just rotating it changes its resistance based on Earth's cosmic path?
That was the idea. It's a bold claim, suggesting a direct, measurable link between Earth's motion through the cosmic fabric and the electrical properties of certain materials. This aligns perfectly with his belief in strong field non-equivalence, where such subtle, fundamental interactions might become apparent under specific conditions or with specific materials, allowing us to perceive aspects of reality previously hidden.
That's a perfect segue into the really deep, complex stuff, his mathematical framework for a unified field theory, delving into the quantum realm and beyond. He fundamentally believed all these forces, electricity, magnetism, and gravity, had a common origin, a single elegant explanation.
He held an unwavering, almost singular belief that electric, magnetic, and gravitational force equations all have the same general form and are therefore likely unified by a common mechanism of action.
The Holy Grail.
Exactly. This is the holy grail for many physicists even today, a grand unification theory that brings all fundamental forces under a single coherent theoretical roof. He wasn't just observing phenomena, he was actively constructing the mathematical language to describe a unified reality.
So he was trying to put them all under one roof mathematically, and he developed some pretty complex expressions for this, like the electrogravitational force quad set equations. What was the key takeaway from those intricate mathematical constructs? What did they reveal about the nature of force itself?
Well, through the elegant and perhaps revolutionary use of complex numbers, numbers involving the square root of -1.
Right, imaginary numbers.
His electrogravitational force quad set equations allowed him to illustrate a total electrogravitational force, which, due to the inherent complex number nature of each force system expression, could result in a negative one of attraction by the accepted definition of force.
Okay, what does that mean? -1 of attraction.
It's a significant mathematical leap. It means his equations could inherently describe both attractive and repulsive forces within a unified framework, moving beyond simple classical definitions where attraction is usually described differently from repulsion. He was arguing that repulsion, too, was a fundamental, inherent part of this unified field.
And then he gets into the truly mind-bending concepts about the nature of reality itself, ideas that sound like they belong in the most far-flung science fiction. He proposed that charge is inside of mass, and that gravitational energy spends part of the time in hyperspace and part of the time in normal space.
Yeah, hold on to your hat.
That's not just a subtle shift in perspective. That sounds like a complete redefinition of space-time.
It absolutely does. He proposed that charge is inside of mass in the form of a quantum standing energy waves, and crucially, that charge squared is shown to be directly related to mass by the geometrical constants.
Wow. So charge and mass aren't separate things.
This fundamentally redefines the relationship, suggesting they are not distinct entities, but deeply interwoven, existing as vibrational patterns within the very fabric of matter. And his intriguing postulate that gravitational waves, since they carry energy, probably are limited to the velocity of light, combined with the even more speculative but profound idea that gravitational energy spends part of the time in hyperspace and part of the time in normal space.
Hyperspace, like Star Wars.
Well, maybe not exactly like Star Wars, but it suggests a reality far more complex, multidimensional, and interconnected than our everyday perception or even most mainstream physics currently allows. It hints at explanations for phenomena we currently can't account for, or even pathways for communication or travel across vast cosmic distances through these hidden dimensions.
This sounds like he was grappling with ideas that modern quantum physics and cosmology are still trying to understand, like the fundamental nature of the electron itself. He mentions Compton electron time and quantum electromagnetic frequency as fundamental units within his system. What did he derive from these very specific quantum values?
His quantum physics work delved deeply into these fundamental units, using them as building blocks for his larger theory. His calculations show that the quantum electron electrostatic field energy could be precisely determined.
Okay.
Then, by dividing this energy by the speed of light squared, E equals mc squared.
Right, Einstein's equation.
He arrived at the quantum electron field mass, which he found to be exactly equivalent to the electron's measured rest mass.
Whoa, so the math worked out perfectly.
According to his notes, yes. This suggested a profound, inherent connection between the electron's charge, its associated field, and its physical mass, implying that the mass itself could be a manifestation of its electromagnetic field energy at the quantum level. This is a very deep theoretical connection that could redefine our understanding of matter itself.
And he went even further, connecting this to one of the ultimate cosmic mysteries, dark matter. How could his theories possibly explain the invisible substance that makes up most of the universe's mass?
Yes, this is truly a leap into the unknown, showcasing the sheer ambition of his theoretical framework. He derived a specific gravitational field mass, m-grav field, which, once created through specific energetic processes, may exist for all time as a least mass energy state and be additive over accumulated time.
Okay, a stable field mass.
He then boldly suggested that this persistent, non-interactive m-grav field could be a possible explanation of cold dark matter, the unseen, non-baryonic matter that accounts for much of the universe's gravitational pull and remains one of cosmology's biggest puzzles.
So his theory might explain dark matter. That's astonishing.
It's an astonishing proposal, weaving his micro-scale quantum insights into a macro-scale cosmic explanation.
That's a groundbreaking proposition, that his theories, derived from experiments on Earth, could potentially explain something as vast as the unseen scaffolding of the universe. And what about relativistic effects? He talks about a relativistic field force that seems to generate immense power.
He theorized that a field mass that becomes influenced by relativistic mass increase, meaning as it approaches the velocity of light, its mass would dramatically increase, could in turn create a very large increase in force field units.
So faster means stronger force field?
Essentially. What's key here is how he proposed to achieve this immense force, simply by creating a switched series of point charges across an insulated surface.
Just switching charges on a surface.
This implies that manipulating electric charges in specific high-speed sequences, even across a simple surface, could generate immense relativistic forces by interacting with this field mass. It's a design principle for propulsion that seems to pull limitless energy from the very fabric of space-time when relativistic effects are fully engaged.
And of course, the ultimate practical application, the one that truly fires the imagination.
Yeah.
Designing craft for interstellar space exploration.
Right, the starships.
He explicitly stated that the very purpose of his complex paper was to present a possible working explanation as to how we humans might construct such craft for the exploration of space. So how exactly did his theories translate into a design for a functional starship? What would one of his craft actually look like, and how would it move?
His designs envisioned a natural spiral nature for the conductive dot charging sequence on the craft's surface. Imagine a series of precisely placed charged points arranged in a spiral pattern.
Okay, spiral dots.
He explained how these current nodes at the end of the waveguides, referring to internal energy conduits within the craft, would be switched sequentially around the perimeter at an incredibly rapid rate, far faster than the natural frequency of a standing wave.
Such a fast switching.
This rapid sequential switching would create a powerful propagating current and a dynamic electrogravitic field. This field, rather than conventional thrust, would provide the propulsive energy, effectively creating the hill for the craft to ride on through space.
Riding its own space-time wave again. And for the immense power required for such a craft, his notes even reference Bob Lazar's controversial claims, which were presenting purely as part of his research notes, regarding antimatter generated from element 115 reacting with the gas for a nearly 100% efficient annihilation process. He notes impartially that element 115 is not naturally occurring on Earth.
This illustrates his willingness to explore even the most radical energy sources, even those far outside conventional understanding, if they fit the theoretical framework for achieving such advanced propulsion.
Whatever it takes.
The core idea here is that the saucer's specific form and internal structure creates a spatial waveguide for both quantum and classic waveguide action, effectively channeling and focusing this immense energy. The propulsive energy, therefore, would depend not on fuel combustion, but on the accumulation of electric charges and their precise manipulation within this unique waveguide structure. It's a complete, if highly speculative system for truly advanced interstellar propulsion, one that leverages fundamental properties of energy and spacetime.
As fascinating and revolutionary as these theories are, the path of a visionary, especially one challenging deeply entrenched paradigms, is rarely smooth. Let's delve now into the complex legacy of his work, particularly the experimental challenges he faced, the persistent doubts that followed him, and the intriguing anomalies he observed. The Montgolfier report, in particular, shed some candid light on the practical difficulties.
Indeed. Early attempts, particularly by others trying to replicate the Biefeld-Brown effect, often proved inconclusive. The Montgolfier report notes fundamental difficulties, like the unavoidable presence of air, and the common use of only one electrical polarity in rudimentary experiments.
Simple mistakes, maybe.
Or just difficult conditions. These seemingly minor experimental details, he argued, significantly complicated any clear observations of the subtle electrogravitic effects he claimed. It highlights the immense difficulty of working with phenomena at the very edge of scientific understanding.
So environmental factors and simplified experimental setups played a huge confounding role. What specific obstacles did these early attempts consistently encounter, leading to inconclusive results?
They observed consistent quantitative irregularities, meaning the measurements were inconsistent and unreliable.
All over the place.
Pretty much. These irregularities were largely attributed to the proximity of the glass bell jar to the moving armatures of the experimental apparatus, which created an unstable environment for distributing the necessary high voltage. This physical constraint caused the observed rotation to slow down and ultimately stop prematurely. Furthermore, experimenters consistently noted flashes within the bell jar, which indicated uncontrolled electrical discharges and energy dissipation, interfering with the delicate forces at play. It was a constant battle against uncontrolled variables.
And what happened when they tried these experiments in a vacuum, thinking that removing the air would solve the problems? Did that lead to more conclusive results?
Well, while in vacuum, the fundamental effect, the condenser still displacing itself positive forwards regardless of the inverse polarity, was consistently observed, which was a positive sign.
Okay, so something was still happening.
Yes, but even in vacuum, the experiments were troubled by the same difficulties caused by the proximity of the inner surface of the bell jar. The electrical fields, despite the vacuum, still interacted with the bell jar walls.
Ugh, still messing things up.
They also observed a diminution of the rotating speed until the apparatus came to a complete stop in specific vacuum ranges. This made it impossible to keep feeding the 40 keV required for continuous operation, again due to more humidity in the air, even trace amounts being significant, and persistent luminous phenomenon, those disruptive electrical flashes.
So even vacuum wasn't perfect. It highlights the incredible sensitivity of these phenomena to even the most minute environmental factors, making robust, repeatable experimentation incredibly challenging.
Extremely challenging.
But despite these persistent difficulties, there were some tantalizing partial successes, right? Some nuances and specific findings that still pointed to the existence of the effect, even if it was hard to pin down consistently.
Yes, absolutely. They found that a reversal in voltage polarity resulted in a reversal of the displacement, confirming that the direction of the force was directly controlled by the polarity of the applied voltage, which is a key aspect of his theory.
Okay, that's important.
They also determined that using lower voltages which produced displacement was possible if ambient humidity was relatively low, underscoring the environmental sensitivity again. And a significant achievement was clocking speeds of 3 turns per second with the additional use of an araldite sphere.
Araldite, like epoxy.
Exactly. A type of epoxy resin used to encapsulate the condenser and completely remove any residual air bubbles. This specific detail hinted at the critical importance of the dielectric material itself and the need for absolute environmental control. These small successes, though difficult to consistently replicate, offered tantalizing glimpses that kept the research alive.
Despite the constant struggle with experimental consistency, his work wasn't just about controlled lab experiments. He also observed and meticulously documented a series of peculiar anomalies and unexplained phenomena that seemed to occur in nature or with simple setups.
This is where his keen observational skills and his willingness to document truly puzzling effects come into play. One particularly perplexing observation was a complete reversal of force due to saturation.
Force reversal? How?
He found that his experimental rig, under certain conditions, initially showed a downward force. But then, beyond a certain threshold, saturation point, the force would inexplicably reverse, causing small metal cans in the setup to lift.
Down then up. Weird.
Even more strangely, there was a null point where no force existed at all in a specific intermediate size range of metal can. This implied a highly nonlinear and extremely complex interaction with the surrounding medium, one that simply couldn't be explained by conventional physics.
A null point. That's really weird. So depending on the size of the metal can, the force could go down, up, or simply disappear entirely. What other strange effects did he notice in his meticulous observations?
He detailed a vertical anisotropy in his sensors, which were combinations of resistors, diodes, and capacitors. This vertical anisotropy meant that the maximum voltage consistently appeared when the front end is up, i.e. toward the zenith, pointing upwards.
Pointing up got more voltage.
Often double the voltage compared to when it was pointed downwards towards the nadir. And this effect seemed unrelated to conventional electric field lines. This strongly suggests a directional sensitivity to some pervasive, perhaps undiscovered field that interacts differently depending on vertical orientation.
So just orienting the sensor up or down had a significant measurable effect on its voltage output. That's truly peculiar. And he even noticed azimuth effects and speculated about an ethyl flow, harking back to a long-dismissed concept in physics.
Yes. When the sensor was horizontal, azimuth effects were observable, meaning the voltage changed depending on its compass orientation. The greatest voltage consistently occurred when the front end was directed toward the south, presumably the magnetic south.
Strongest pointing south.
This effect further increased when aligned precisely with magnetic declination. Based on these observations, he speculated this might be indicative of an ether flow from the Southruff-Miller interferometer observation.
The ether flow, like the old ether theory.
The concept of a luminiferous ether was a pre-Einsteinian idea, largely dismissed after the Michelson-Morley experiment. His reintroduction of it, based on his own anomalous observations, demonstrates his willingness to reconsider discarded scientific paradigms if his data suggested it.
This is truly pushing the boundaries of what's conventionally accepted and perhaps even resurrecting old ideas in new forms. And his ideas, as we mentioned earlier, weren't always met with open arms in the scientific community, to put it mildly.
Absolutely not. He repeatedly reiterated in his notes that his early thoughts on gravitationally anomalous materials, the idea that you could alter the weight of objects, were considered rank heresy in respectable scientific circles.
Rank heresy, there it is again.
This initial vehement skepticism highlights the formidable challenge of introducing concepts that directly contradict deeply established scientific paradigms, especially when they touch upon fundamental forces like gravity.
And it seems this skepticism, or perhaps something more, even extended into government circles, with conflicting government reports being issued about his work. How did that complicated landscape unfold?
Well, his associates, those working closely with him, were reportedly stunned by the seemingly contradictory conclusions of an official report. This report, produced by a government scientist, concluded that all of Brown's discoveries could be explained using classical physical principles.
Explained away, basically.
That's how it seemed. This is a stark contrast to his own findings and interpretations, which clearly pointed to new physics. It strongly suggests a deliberate attempt, whether for reasons of misunderstanding, scientific bias, or perhaps even national security, to downplay or reframe his truly revolutionary work in a more palatable, conventional light.
That sounds like a classic case of official denial or maybe obfuscation. And there were also explicit security concerns surrounding his research, indicating its sensitive nature, suggesting that perhaps not everyone in government fully dismissed it, even if public reports did.
Oh, definitely. The internal discussions reveal serious security issues and the palpable need for a controlled situation to avoid aggravating some very important people here concerning the development stage of the project.
Ah, very important people.
This strongly implies that even if the public reports downplayed the work, there was an internal recognition of its profound potential significance and a strong desire within certain circles to control its narrative, its progress, and its very existence. It creates a fascinating tension between public dismissal and internal strategic interest.
So while some dismissed it publicly, others were clearly concerned about its implications behind the scenes. Interestingly, despite these internal issues and the domestic skepticism, there was significant international interest in his work, wasn't there?
Indeed. French scientists in particular were profoundly interested in his findings. They invited him to France to formulate an international research project proposal that could specifically include the American government's interests.
So the French were keen.
It clearly underscores that his radical ideas resonated with some researchers outside the immediate sphere of U.S. government skepticism and official narrative, suggesting that the scientific community beyond American borders was perhaps more open to these unconventional concepts.
And through all this, navigating the skepticism, the challenges, the intrigue, he maintained a remarkable perspective and even a wonderful sense of humor, didn't he? It seems his spirit remained unbowed.
He absolutely did.
Ah.
There's a fantastic anecdote from his visit to England where he was thrilled because he believed the Ministry of Supply, MOS there, which was the British government department responsible for military procurement and research, understand more about this than he does. It's a witty jab at his own government's apparent lack of understanding or acknowledgement.
That's great.
And his dry, self-effacing remark at an air staff banquet is classic. After dinner, they tried to pump me with no success, for I do not drink.
Love it. Can't be pumped if you don't drink.
It shows his unwavering confidence, his sharp wit, and his unique personality, even as his truly radical ideas navigated incredibly complex scientific and political landscapes. He truly was an original, a singular mind.
Okay, let's try and wrap our heads around all of this.
So what have we unpacked today? We've journeyed through the extraordinary life and mind of a scientist who was, in many ways, an anomaly himself. From a teenage radio pioneer sending broadcasts across an entire continent to someone proposing new fundamental physics that challenged Einstein.
Yeah.
He truly dedicated his life to one singular, astonishing idea: the intimate, controllable relationship between electric fields and gravity. His persistence in the face of skepticism, his meticulous observations of unexplained phenomena, and his audacious theoretical leaps paint a picture of man utterly consumed by the pursuit of knowledge.
It's a story of profound intuition, bold experimentation, and theories that push the very boundaries of conventional science, reaching into realms that still feel like science fiction, whether it's making materials lighter than air, generating power from common rocks, or imagining starships propelled by precisely manipulated charged surfaces. His vision was consistently mind-blowing and persistently ahead of its time. His work is a powerful testament to the transformative power of unconventional thought, even when it directly clashes with the established norms, inviting us to keep an open mind to possibilities we haven't yet fully grasped.
And his insistence that equivalence exists only when weak fields are present or utilized raises a fundamental, almost chilling question. Are there aspects of gravity, or perhaps even the very fabric of the universe, that we're simply not observing because our experiments aren't strong enough, or our tools not precise enough to reveal them?
Right. Are we missing something big?
What if the universe holds secrets that only reveal themselves when we push the very limits of our current understanding, or design entirely new, radical ways of looking at reality?
And if even a fraction of his proposed applications like propulsion without moving parts, or self-charging batteries for mundane concrete blocks, or a fundamental way to make objects lighter were fully realized, how would that fundamentally, irrevocably change our world, our technology, and our place in the cosmos?
It boggles the mind.
This deep dive leaves you with the tantalizing, awe-inspiring thought that perhaps the most impossible ideas are not impossible at all. They are simply waiting for us as a civilization to catch up.
Thank you for joining us on this incredible deep dive into the truly extraordinary.
Keep those curious minds open, and we'll see you next time.